In our Python course, we talked about this range function in Python, which is very useful in creating different sets of one-dimensional values. Right here, what we're doing is creating a Python list with a range of 15. If we output this, you'll be reminded that it automatically starts at 0. It goes to 15, but that 15 is not inclusive. Let's say we put a 5 in here before the 15, and this is going to tell it where to start inclusively, and this remains where to end, but exclusively. So let's run this, and it starts including the 5, and it ends excluding the 15. And now if you recall, there is one more parameter that we can put in this function after the 15, which tells it how many steps to take as it assembles this set of values. And here we're telling it to take steps of 3. So start at 5 inclusively, end at 15 exclusively, and take steps of 3. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In NumPy we have a comparable function called arange, and it's actually built off of the Python range function, but instead of creating a Python list, it creates a NumPy array. And it operates under the same conditions. So we could put a 5 here to tell it to start with a 5 inclusively, and we could put a 3 after here to tell it to go in steps of 3. We can check the data type of this array. We find out that if we do not define the data type that we'd like, that NumPy simply takes its best guess and defaults here. But what happens if we put a .5 in here? It creates a set of floats, and what happens if we run this dtype again? NumPy has made the decision on its own what kind of data type that we're using here. We can, however, add a fourth parameter here where we define what data type we'd like. If I run this, it's created floats, and you notice the difference with floats. It puts periods. Even if there is no decimal value, it still puts a period in here. What happens if we change this to int 32? Int 32 and run it again. Well, it doesn't give us the data type, but we can guess what the data type is. Yeah, it's an int 32. With NumPy, we can actually convert data types. One thing to be aware of here is the concept of data loss. So we're going to create a float array here to demonstrate this. Obviously, these are floats because they have decimal values. And what happens if we turn this float array into an integer array using this asType function? Let's try it and see what we get. Well, we've gotten integers that match. There's a 1 which matches, and 2 which matches, and the 3 and the 4, the 5 and the 6 all match, but we've lost data here. So that's something to keep in mind. What if we create a string of numbers? We have these numbers existing as strings as denoted by the inclusion of parentheses around them. Let's say we want to change these to floats. We use the asType function again, and it's changed them to floats. Now we've not lost any data here, but it's important to note that we can lose data here by converting these strings into floats in NumPy. So there's better ways to do that in Pandas, which we'll talk about in our next course. Another thing to consider here is we've been a bit lazy here in declaring our data type. If we run this, it has decided to make these int 64s. So there's one more way to assign a data type that we're going to look at here, and this is inheriting data type from a different array. So what that means is if we create a new data type called stringArray3 and we explicitly give it this string data type, then we can take stringArray3, we can change the type to the stringArray2 data type. And we know the stringArray2 data type is a float 64 from our last code execution. So let's do this step by step. Let's create this and then output it. So it tells us right here it's a string 5, and these are floats within string variables, confirming that, surprise, surprise, no conversion has been made. And that's because we have to put it into a new variable. So let's create a new variable called change equals that. And then instead of outputting string array 3, we output change. And run this again. And we get our conversion into float 64. And if we run the data type, we can confirm that